Hey everyone, this is Derek, and it's going to be a short little video on properties of logs. I'm going to start with some that are not exactly properties, but they are things that, what just came to mind was kind of almost like sight words. If you've had a kid in kindergarten learning to read sight words, these are almost like sight words in math. They're things you just want to look at and go, that's a 0, that's a 1, that's an X. So let me show you how to do that with these natural logs. So anytime we have the log, whether it's log or natural log of 1, it's going to be 0. And the reason for that is if you think of, say we do something easy to get a head around, log base 5 of 1 equals something. 5 to the what makes 1, 5 to the 0. So any log of 1 will equal 0. ln e, this is the same thing as, right, log base e of e. So what power do I raise e to get e? Well, 1. And so ln e is just a fancy way of writing a 1. Here, when we get to the next page, we're going to learn that this x can come down front, and that will be one of our properties when I do the full version of the properties. Once I do that, then remember ln e back here was a 1, so that's just going to make that be x. And so again, I like the analogy of sight words, actually. This is very much just kind of look at it and go, oh, what would that do? And then see the answer, hopefully. So for this first one, let me bring this 4 down front. And minus ln 1. So this is really 4. ln e, we just decided up here was 1. ln 1 is 0. And so that whole mess is a big fancy 4. And so that's kind of what I'm trying to get to with these, is something can look terrible and then really not be a big deal. For this one, again, I can bring this down front. This one happens to have a 15 writing out front. So let me bring that exponent down front. I'll have 2/3 times 15 ln e. ln e, that's a 1. So again, drops out. This becomes 30 over 3. And then also known as 10. So, okay, here's the real properties. So first property goes, if I have log of xy, I can rewrite that as log of x plus log of y. If I have log of x divided by y, and notice that this isn't log of x times log of y, so there's only one log happening. Likewise, this isn't log x over log y. This is a single log with stuff happening in the argument. But so anyhow, when they're multiplying, it's addition, and then when they're dividing, it's subtraction, and that's the same as our properties of exponents. If I have a to the x, a to the y, that equals, a to the x plus y. If I have a to the x over a to the y, that equals a to the x minus y. So remember, the logs are just exponents, so this is just our properties of exponents. Property 3 here is the one that I kind of alluded to in the last page. If I have an exponent, I can bring it down front and multiply. That is actually our a to the x to the y, and then we would multiply. And then we saw this in the last page also. If the base of the log and the argument are the same, so like for instance, log base 5 of 5, that's what do I raise 5 to the 5? That's a 1. So every time these match, that's going to be 1. And like I explained earlier, log of 1 will be a 0. We also ran into, in the last example, that x to the 1/2, same thing as square root x. And in general, if I have, x to the 1 over n, so say n was 3, that would be like a cube root of x. And it's important to be able to get from fractional exponents to root notation and back and forth, because we have all these properties up here. Well, we have this property here where we can use exponents, but I have to make it look like 1 in order to use it. Okay, so with this, we're going to do a couple of different things. First off, we are going to expand the log. So we're going to write it as a bunch of different little logs, and then we're going to take a bunch of logs and write them as a single log. So basically, we're just kind of going back and forth. If I were trying to solve this, I would absolutely want it as a single log. If I was in Calc next quarter, this would be terrible, and I would want to be able to rewrite this as the expanded version. So it just sort of depends on what we're trying to do with it. So expand the log as much as possible, rewrite it as sum difference or product of logs. Okay, so this one has division, so that means it's going to be the subtraction version. So we're going to have log base b of 7, and then that will be minus log base b of x cubed. But then I can do one more thing here, which is I have this, if I have an exponent, I can bring it down front. So then I will bring that down front. So log base b of 7 minus 3 log base b of x. So the two things I want to point out here, this was 7 to the 1. That has a little 1 coefficient on it. It's positive. It came from the numerator. The x was at a 3, and I end up with a negative 3 because it came from the denominator. So what that means is every time you have an exponent, it's going to be your coefficient. If it came from the numerator, it's going to be positive. If it came from the denominator, it'll be negative. And once you kind of figure that out, these are all super easy. So for instance, this one has kind of 1, 2, 3 things happening. So I'll have 3 logs. The first one's going to be a log of x, if I preserve the order. And that will be ln x. So it's going to have a coefficient of 4. It'll be positive because it's from the numerator. Same thing here. I'll have plus 2 ln y. And then this one's from the denominator, so that's going to be minus 7 ln z. And the reason is, if I rewrote this, right, I could write this x4 y2 z to the negative 7, and then just apply this rule. And you see how when I bring that down, it's going to be negative. So you can really just do these all in one step often. And you're just saying, you know, whatever's in front is an exponent. If it's negative, it has to be in the denominator. If it's positive, it's got to come from the numerator. Okay, so then these next examples are going the other direction, where we're going to write as a single log or condense the expression to a single log. And then we're also going to want to simplify if possible. So remember this, here's kind of the really common thing that people do wrong on this. When you see this single log, you shouldn't end up with like, that was a terrible looking log. Log of some stuff over log of some other stuff with times some log of some more stuff. There should only be one log in your answer, right? Because you're writing it as a single log. So careful to kind of get yourself set up. I see a lot of log over log right here is the issue. So this would be like ln a minus ln b, so that'd be like an a over b situation. So it's going to be 3x to the 10 over 18x8. And then this reduces a little bit, so we want to be careful to get that simplified. Ln here, you can think of this as a 3 times a 6, isn't a bad way to do it. And then what I'm doing here is I'm kind of thinking x to 8 and then x squared. You certainly do not have to write all this. This is just to kind of hopefully help people remember how to cancel. So what I did was I kind of factored stuff out so that the 3's, I can show those canceling. It's going to leave me a 6 on the bottom. If I have 10 x's up top and I have 8 down below, I'm going to have 2 left. And that's because 8 of them are going to cancel, and then those are the 2 I'm going to have left. So hopefully that visual helps you see what happened there. X squared and then over 6. For this one, let's see. So we're going to have, remember, just one log. And I'm going to write that better. I think I'll write it like this because we're going to have some multiplying going on. So this is going to be an a to the 5th. And then this is in parentheses, so a minus 2. And then that would be like cubed. And then because that's addition, those two things would be multiplying. So that would be it. Okay, and then this last one, so I'm going to have log, and then I'll have an a with a cube, and that's positive, so it's coming from the numerator. I'm going to have a b with a 1/2, but it's negative, so that one had to have come from the denominator. And then the sign changed. Remember, I could have just written these in the other order, so the fact that's in the middle is not significant. It's just that it's minus. So here, c to the 5th, because it's positive. The other way to write that is log a cubed, worst a ever, c to the 5th, and then square root b. I think the computer should take the 1/2. If not, use the root. And then the other reason I want to point it out is because if you have the root and you're trying to get to here, you got to know to make it the 1/2. Cool.